Welcome back to Topic 10 for Algebra 2, Piecewise Functions. In Part 2, we're going to learn what is a piecewise function by first comparing it to an absolute value function, as well as learning how to evaluate a piecewise function. So in Part 1 of Topic 10, we learned all about absolute value functions, how to graph them, how to write the equation for them, etc., etc. So if we look at this absolute value function on the right, I want you to think about what would be the equation that would represent it. So we have f of x equals, now the vertex of this is at 3, 2. So remember, when we have the absolute value, it's the absolute value of x minus our h value, which is our horizontal shift. We're shifting 3 units over to the right, and then plus our k value, how much we're shifting up or down vertically. In this case, it's up 2, so plus 2. We're not reflecting at all, and we don't have any vertical stretch, so we're all set. This is our equation. However, we can also write this function another way. We can write it as a piecewise function. So we can have f of x equals negative x plus 5 when x is less than 3, and x minus 1 when x is greater than or equal to 3. So it's a piecewise function because there are multiple pieces to it. There are multiple parts to it. Now I want you to look at this graph. We're going to go more in detail on how to actually write the equation of a piecewise function. But in this absolute value function, I want you to think about it as two separate functions together. So our first one, we have this line right here. If we look, it has a y-intercept of 5, so that's where my plus 5 is. And our slope is down 1 and over 1 to the right. So that's where we get our negative 1x. So we have this line until we get to 3, this point of 3. So when x is less than 3, we have this line. As soon as x is 3 or greater than 3, we have a different line. We have this line right here. Now it might be difficult to determine the equation to this line, so what I like to do is we can figure out what the slope is just from looking at this graph. So we're going up 1, over 1, and that's consistent. So we can sketch our graph to see where it would end. If we continued our point right here, right at negative 1, that would be our that would be where our y-intercept is. So the equation of this line right here, as it's a little messy, is x minus 1 when x is greater than or equal to 3. And because this is a closed circle, or we have a solid line here, that's why it's or equal to right here. So we're going to get a little bit more information about how to identify piecewise functions later on, but I just wanted to show you that you can actually write an absolute value function as two different functions or a piecewise function. So a piecewise function is a function represented by a combination of equations, each corresponding to a part of the domain. So just like in the example before when we had x is less than 3 and x is greater than or equal to 3, that's referring to the domain. That's referring to our x values here. Now we can also learn how to evaluate a piecewise function. So if we're given our example here, evaluate f of x when x equals negative 3 and when x equals negative 1. So if we start off with x equals negative 3, we know that negative 3 is less than negative 1, right? So we're going to use the first function. We're going to use this top one up here just because of the instructions that the domain gave us. So we're going to have our -3 plugging in for x minus 4. Actually, let me rewrite that. I should say f of -3. So when we plug in -3 for x, we get -3 minus 4, which gives us -7. Perfect. Now if we look at our next example, we have x equals -1. Now we actually want to use the second function here, and I'll tell you why. We want to use 3x minus 1 when x is greater than or equal to -1. Well, -1 is greater than or equal to -1. So -1 isn't bigger than -1, but it is the equal to part of it. So we're going to use the second function. So f of -1 is going to equal 3 times -1 minus 1. 3 times -1 is -3, minus 1 gives us -4. And that was part 2 of topic 10 for Algebra 2 on Introduction to Piecewise Functions. Thank you for watching.